Okay, hello all humans watching. Welcome back to my stream. I haven't been streaming in a while. I was on vacation and stuff. But yeah, now I've been working away on my game. And I thought today I will do sort of a demo of uh, two like interesting things. So I will go through the code and we'll see you'll see what I've made. And the first thing we're gonna look at today is what I call a simple undo system. And this is based on what's become known as Undo for Lazy Programmers, which is an article by Dennis Gustafsson at Voxagon Labs. The person behind Teardown. So undo for lazy programmers is essentially that, undo usually means, you have maybe you need to have like small commands, and those commands tell you like, you did something in the game editor, and this is how to do it, this is how to undo it, and then you have to make all these small commands for it, or the alternative is to have a really nice data model to back things up. However, what Dennis talks about here is that you can instead, if like in the case where you have maybe a small enough game so that you don't have so much data, what you can do is whenever you do something that you want to be undoable, you serialize the whole state of the currently edited level and whatever other editor state you want to have undo for, and you save that on a sort of stack. So that's what this article is about. You can find it if you Google this, undo for lazy programmers. So let me just show sort of how this works in the game currently. Boot it up here. So here's my game, by the way. I have done some work. I've done some animation and stuff, and there is you can talk to these creatures, blah blah blah. And then there is also no, I messed something up because I took up an item from the squirrel here. There's also this rocket you can fly around. The rocket is supposed to have like this fancy start sequence when you fly away, but I currently disabled it because I wanted to toy around with flying like this. Anyways, that's how the game currently looks. So there is an editor in the game. If you press F2, then you have a bunch of different options here of what to do. So you can place some tiles, you can place entities, you can also edit the different entity types. So when I place entities here, I place these three and I press Ctrl Z. These are undone and I can redo them again. But what happens here each time I do that is actually that the when I click here, after it has placed this tile, the whole state of the level and also the entity types, which is the totality of all my state, is serialized and put on a stack. And then it just goes, when I press Ctrl Z, it just goes backwards once in the stack and sort of resets the whole editor state, and also in this case the game state, to whatever is at that point in the, whatever serialized state that one is. And this is sort of, this is the same serialized state that I use when I save the level out to disk. It just, it's not, it's not the sort of, it's not the text version, of course. It's the binary version. It's just a struct with all the different tiles and placed entities and stuff. And I put those on a stack, and I'll show a bit more of that soon. So, and I can also place these entities, and I can undo that like that. And I can also go in here. This is my entity type editor, where I have these are the different entity types I have, and down here I can select which graphics they should have. And this is the tree stump you can see in the game, and in this editor I can make here I can drag a collider. This is the collider box, this one we'll use in game, and then I can undo. And this actually this is not in part of the level, this is part of the entity types definition, which is also something that is serialized. I can also go here, this is my waterfall that's in the game. I can click the frame time down here and I can go and sort of edit that, press enter, and it goes much faster, and then I can undo it and it sort of works. So what happens here, like I said, each time I press Ctrl Z, it deserializes the whole state of the level and the entity type definitions to get it to the state it was before I did anything. Let's look a bit at the code for this. So we have serialized, let's see here, where are we? Game.odin, yes. So when we have, we can start with, yeah, serialized state. Oh yeah, that's in a separate serialized state. So this is my serialized state. Wait, I'm just gonna check something here. I don't talking nonsense. Editor memory. Yes, exactly. So my serialized state is a serialized level, which is sort of the level, and then it's the entity type definitions. And the entity types is that's like the, you know, I could edit the waterfall and the tree stump and whatever. And whenever I then do something, then the function record undo is run. So we have some example here, I think. So we have, this is the code that's run when I'm in the tile editing mode, like this one. And when I'm in this mode, it checks if the left mouse button is pressed, then it will make a new tile and append that to the list of tiles in the world, sort of. And when it's done all that, appended it, then it says record undo. And if we go to record undo and look what it does, then it, well, the most interesting part is down here. It serializes the whole state, and this thing takes, this is quite a big function, but this one essentially takes whatever runtime representation I have, and it makes one of these serialized state things, which is what is possible for me to marshal out to disk when I actually click the save button. But in this case, I only use this for undo and redo. Yeah. Anyways, so when record undo happens, it serializes the state and then it pushes it to the undo stack. And I can bring up another. If we go to editor memory. So the undo stack lives here, and the undo stack is just a dynamic array of serialized states. So it's a dynamic array of these guys. Yeah. And then there's also an int that says which is our current undo step, what index are we at in this undo stack. So when you record an undo, it will take serialized state, append it to the undo stack, and then say that the current undo step is the last one in the undo stack. But as you know, sort of like when you in Photoshop, for example, you do a brush stroke, you do a couple of brush strokes, and then you undo the two most recent ones, and then you do a new one. Then the sort of, you know, the ones that are ahead of you in the undo history, those are removed. So you're sort of, you know, going in a new direction in the history. And that's what this code does. So if I undo these two and click here, then when I undo, those two that were there are gone, which is what you expect. And that's what this one does. It says if the current undo step is not the index of the last element in the undo stack, then it will remove from the undo stack just that last chunk of things. And then at the end it will do, like I said, do this stuff, serialize and put the current state on the stack. Have some coffee. This is the nice afternoon coffee. Let's see here. So that's record undo. Also about this undo stack, so I make sure that when I load up the level, when I initialize the editor at the start, I think this is in game init currently or something, then it actually the initial state. So if I reset the whole game, so this is the initial state of the game. This state that it has is pushed as the first, at index 0 is the initial state. And that sort of simplifies things a bit, because in how you like handle this current undo step index and stuff. Yeah, and then there are, of course, you don't just record undo, you undo and redo. You do the actual actions of that. So we can go to find what is that, like it's like .z. Here you go. So when we're in the editor mode, this function is run, and then if you press Z while holding left control, it will perform undo. Or if you press Y instead, it will perform redo. And what these functions do is that perform undo will check. This just does some, so we don't run out of bounds, but it just decreases the index of the current undo step by 1, and then it fetches the serialized state at that index, and then it deserializes the whole thing. And this deserialized state is what initializes the whole state of the game and the editor and the stuff. And perform redo then, of course, does something similar, just advances and then deserializes. And that's essentially it. Now there is of course some discussion here to be had, like, okay, is this a good idea performance-wise? Well, in a smaller game where you, especially if you're using your custom code, like you're not using if you're not building a big game engine for general use where people can build anything, you sort of know what's going to happen. Then doing this is not a bad idea, because it is very fast. I mean, now it's deserializing when I do undo and redo here. It's deserializing and reserializing the whole state. And this level has a bunch of tiles and stuff, so all these are reloaded from the thing. And a question from the chat is, so you store the entire state and not the diff? That's correct. It's the exact same stuff that I saved to disk when I click save in the editor, only it's the serialized version, like the binary version of that. So it's this whole thing. Saving just the diff. This is so fast that I haven't even considered that. I don't know what the implication. It's probably a lot more complicated, I guess, to constantly know, because then you need to know, like, what is the diff, like just knowing which things in the whole game in your editor are things that. Oh, there's a baby screaming. Close the window. Like, knowing what the diff is, which tiles have you changed, what have you done, then you need to do much more bookkeeping. So this becomes very simple, and it's like I said, it's based on this article, Undo for Lazy Programmers, and it is indeed a lazy way that will work for many smaller games. This article is a bit old. I think it's maybe before, so he worked on Teardown. I want to ask him sometime if he did this in Teardown as well, because so Dennis Gustafsson made lots of smaller games comparatively to Teardown. So I think I'm gonna ask him sometime if he did this on Teardown as well, because that would be interesting, because that's like a voxel game, so it's pretty intense actually. So it's not a small game at all. So this is, for my purposes, like it's fast enough, and also since I'm just I'm making my custom editor and everything. I know the sort of limitations of my game. I know I won't go like, I know in which directions I won't go crazy. So yeah, it works well. There was something else I was thinking about here to discuss about the undo. What was that? What was that? Perform. So we showed perform undo, record undo, and we showed how this thing works. Maybe I forgot. But I can, so a couple of different examples here of just how this looks in code. So what you do is you always run record undo after you've done something because it serializes the whole state. So it's not like when you have more of a data model approach, say that you have a data model with built-in undo instead of doing this, so where you kind of calculate diffs and stuff instead. Then you would probably say before you do something like, oh, now I want to do stuff that's undoable, and then at the end of doing that stuff, you have to say, now I'm done doing stuff, and then it's sort of like, okay, here's the change. But this you only use record undo after you've done stuff because it's the whole state. And some example, I showed a tile example, and we have other things like if I press X while holding left shift and there is a tile under my cursor, I can flip the direction of it, and this is undoable. So now I can undo that back and forth. I also have, I can hold the K button here, and these numbers that come up is the layer all tiles are in. And I can hover something and press L, and then oh wait, I need to click this. I can hover something and I can hold K, hover over a tile and press L, and then it changes the layer. This is the fast way. And then you see sort of how this comes in front of the tree stump there. And then I can, of course, undo this back and forth. So it's very easy to, because making a good enough data model so you have built-in undo, that takes a lot of time, and you will not be able to focus on your game if you're just trying to make a quick, like trying to get your game running quickly, especially if you're doing it, outside of a big, like if you're not using, an off-the-shelf game engine and that has built-in undo, and you don't want to make your data model, then you either have to do something like commands. So commands, for a command, for example, it would know like, okay, when I place a tile, I click the left mouse button to place a tile, then it knows like, okay, this is what this command does. It places the tile. And then there is a way to unplace it. And it can, the undo history is a list of those commands that can go back and forth. That's been done a lot, but it's very annoying because anytime you want to do anything in the editor, you need to go like via some commands, and the code in your editor becomes very messy, and there's a lot of friction in adding new things in editor because you need to wrap everything in a sort of command. Yeah. So then you're left with, well, then one idea is to do this instead, which will work fine for a smaller game. Let's see what I'm just gonna think if there was anything else I wanted to say about the undo. Oh yes, there is. Now I remember. So there are of course there's a couple of different ways to do undo. If you have a separate editor, like for example, you see I can in my game I can run around and jump blah blah blah, and then I can place some tiles like this, and I can go back and I can jump up on them. Now all games don't do this. Like you don't do in all games that you have a. You don't do in all games that you can that the editor is inside the game. Many people use something like Tiled or one of those external editors, and then they bring it in. But I've just made my own editor inside here, so I can quickly do this. Now, this of course has some implications because whenever I do this, click, and I undo. Now it has twice, because I removed these two, so I click here and I and I undo that. Now it deserialized the whole state, which means it sort of reset the whole state. And my game and my editor, it has a separate state for the editor, which is sort of the original state, because some things like the player character will move around. So there is an original state. However, it still resets the state of the whole game. But then there are, of course, some things like, okay, but your player is standing here. So I just do a very easy thing here, like things that I know that will move around, like my player, I will make sure to remember where they were at when I deserialize the state. So I have like, I think, is it here? Yeah. This is my deserialized state function. So at the start of this, I make a copy of the two different player characters, and at the bottom, if I had a player, if I have a copy of the cat at the end of my deserialization, then I make sure to move over some state data for that one. And because if I don't do this, then this would happen each time. Like it would reset the game because I end up back at where it should spawn. There's of course different ways to handle this, and this is one of the downsides of coupling your editor and your game too much, but it has, you know, other benefits. Now, of course, I only copied this cat and the rocket thing. You could have lots more state in the game, other characters walking around, and then that would be a problem. And you could probably, you know, make this a bit more abstract, so there is some kind of, and okay, maybe you could tag up entities that are already spawned, and you know, have a position, like for every entity that is tagged with something specific, like yeah, you tag it up with something so that it knows that it wants to copy over the position and whatever state you want for that one, and then you could have a bit more of a less hard-coded version of this. But that's just what I do to fix that little problem. Yeah, so I think that's that for the undo stuff. So I recommend, I mean, I've done all different kinds. I've worked on game engines that have the big data model. I've done my own like command-based solutions, and yeah, this is by far the least error-prone and the easiest to make version that would work if your game is small enough. So let's go back to my list of today, what will happen. So I want to talk also a bit about my entity system. Now, entity systems is this, it's almost a loaded topic because it almost seems like people have landed in this opinion that like both for the sake that people almost seem to have landed in that you should have an entity, what's known as an entity component system. That's like what people think, it seems like. Okay, I'm not saying all people think this, but it's often, you know, like if you're doing your own game from scratch, people be like, oh, just do that, that's the easiest. And I would say that choosing how to work with your entities is the biggest, like most important architecture decision for your game, because you know, gameplay code is essentially about one thing in the world affecting another. So how you structure that is your biggest, it's one of your biggest early design decisions, right? And I think entity component system, I mean, when I say entity component system, I mean sort of, you know, the more data oriented thing where you have like entities are maybe just some kind of small thing, and then there's a data oriented structure containing all the different components, and it can cache friendly sort of go through them and stuff. You know, it's sort of like where Unity is trying to move with the dots and stuff. That's what I mean. I think that entity component systems are, yeah, sure, they're good for parallelization and cache like performance and stuff. But it's especially when you're just trying to experiment around, because of the nature of how they are, it's a bit hard to be experimental. For example, if you compare like Unity's like classic Unity with their less data-oriented component system, whatever you want to call it. It's so weird that entity component system, that word implies this sort of more data-oriented thing, when I would, like from the name, assume that Unity's current system, the classic Unity system, is an entity component system because it's the system of entities with components. But doesn't seem what people mean. So, you know, but anyways, in sort of classic Unity, the old Unity component system, that one is quite easy to work with and quickly do prototyping, which is sort of why Unity became so popular, right? Because it was easy to get going with your game. And then maybe if you made a really big game, then you maybe had some performance problems, partially because of how they implement things, and partially maybe because this component system they have is not very friendly for threading and caches and stuff. But anyways, I think that component systems in general, they have a couple of downsides, and one of them, no matter if you do it like the data-oriented way or the more classic Unity way, one downside of it is that they tend to be, how to say, like this, you run into interesting problems with like script execution orders, and like what is your game actually doing. You know, in Unity you have the script execution order configuration tab and stuff, and that one is not knowing what the sort of update hierarchy of your main loop in your game is. To me, is one joy of sort of making software is to at least know sort of what it's doing, like sort of knowing what order is it, what is it doing, and in what order is it doing it, and it just becomes a bit ambiguous to me with component systems. So, you know, another alternative to this is in more object-oriented like the designs of games. You know, some people would have like a base entity, and then they will have a couple of different entity types that derive from the base entity, and those do different things. Now that's I don't know. First of all, I'm making this in Odin. It's not a very it's not very friendly to this kind of object-oriented mindset, which is sort of why I try to do something else. And then at some point, maybe you want to combine different behaviors a bit. So you want a bit more freedom in how things are set up. But in this case, it sort of becomes like, oh no, an entity is this, and then it has these variations and stuff. But anyway, so what I've done is, since I have a kind of a bit smaller game, I have just my entity type is here, and I have an entity, and by the way, the entities have a handle. So the entities are stored in a handle-based array, sort of. So you never store a pointer to an entity, you store a handle, and that's just to not get dangling pointers and stuff, and I can talk a bit more about that later. So the entity has a handle, and it has a couple of different things that are in common for entities. like there's a flag for if it's hidden, what the position is, what layer it's on, and this is the which type it came from inside the editor. And then I have a big union of all the different types. And this I think works quite fine for a game, like a simple game. So this of course will make your entity type bigger, like it will be as big as the biggest one of these. I don't really think this will be a big problem. Like, for example, my tiles in the game aren't even entities. They're a separate thing. So there aren't so many of these. So that's fine. So that's, and I just want to point out that, of course, people have done this many times before, but there is some extra things I've done here to make it nice to work with, which is what I want to show, and it uses some nice Odin features. So whenever you create an entity, which we can look at sort of here, somewhere here is the code for here's the code for spawning the cat in the game. So it says it makes an entity with a position and some stuff, and then the variant of it says, okay, this one is a player cat, and then the player cat has a lots of state inside it. This is probably the biggest one of all my entities. And then at the end it runs add entity, and add entity is a function that takes a pointer to this entity and then adds it to my handle-based arrays. And I think I made a video on handle-based arrays before, but it's essentially just a handle in this case. Entity handle is a handle, and handle is an index plus a generation, and it's used to what you return, what you store if you want to have a reference to an entity is a handle, which is essentially an index plus a generation to make sure that slots that are reused are not. You know if your slot has been reused at that current index. So let's go back to my spawn entity function here. So it wants to add the cat, and then it runs add entity, like I said, and then it adds to the handle-based array entities. It adds the entity, and then the return value of this function is just an entity handle, and that's what this add entity thing returns. And now we come to some interesting problems with both like this way of doing things and handles, and that I can show in this way. Wait, I have to cough. I'm drinking coffee, so I cough. Anyways, so for example, I think in spawn entity here, I think I store, so when I've spawned the cat, I store that as a variable in my global memory blob called cat game memory. Where is it? Here. So this is an entity handle. This is not a pointer or anything. Of course, if you want to use this entity, then you must resolve it to the real entity, sort of. And I think we'll have some gmem.cat. I'm gonna just find a good example here. Want to see. Do I do this somewhere nice? Yeah, here we go. This is what I wanted to show. yeah, this koi. So when you if you want to fetch the cat entity, you would do something like this. Cat equals get entity gmem.cat, and then I would say also which type I expect it to be, because just a handle is an untyped entity handle. So I say player cat. Right. Now, so that then this, what you would get from get entity is an entity instance, and this is the reason I use this instead of just a pointer to the entity is because it become like I already know at this point that what I want is the player cat. So then, for example, this update player cat will take a player instance that says, okay, I expect a player instance of the type player cat, right? Yeah, and then this entity instance in turn is just a struct that has two fields. One is the entity and the other is the variation. And the reason this is very nice is that usually if this, so I could have written this like this, you know, like that. Oh, this just takes the player cat as an entity. But then, as you've seen in entity, the variant is in here, and it might be player cat, but I would have, in order to change any variable of this player cat thingy here, I would have to do something like if p.variant.player cat, and then I'd be like, okay, cat var okay equals, and then okay, and then in here I know the variant. But I want this function to, through some type safety, be able to expect that this is an entity of type player cat, right? And this, and like I said, I can't just, and I don't also just want to store a pointer to the, I don't want to do this either, just like this, player cat, because the player cat does not have the common things up here, you know, the position and whatever. So what I do instead is this thing. I do an entity instance of player cat. And so this one says using entity, and so it's this one entity pointer, and there's one pointer to the variant, which in this case will be the player cat. And since it says using in front of here, I can, on p, I can say p.pos equals, and then I can say a number, but I can also say p. What is player, some variables inside player cat, blah blah blah, grounded. I could also say p.grounded equals false, and I can do it like that, which is exactly what I wanted. If like I get sort of the best of both worlds, but as usual, this entity instance is resolved from an entity handle usually. So you can't save this entity instance anywhere. It's just for convenience, you run get entity, you get the entity instance, and then you can pass that around to make your code work very nicely and behave very nicely. But you yeah, so I don't know what I was saying there. What I was saying is you will never put an entity instance inside a struct and save it. You will still only save entity handles, but you can, like during a frame, of course, you can have functions that take this, so you can pass it around and then operate on it just as if it was one monolithic object. And maybe I have some more examples. The reason my example wasn't so good here, I can show you, is because in this specific case I didn't use get entity here, because this one iterates over all the entities, so I do something else here. So I wanted to find a better example. Yeah, this one actually does it. So this is function I'm going to remove. This one says get this entity. I expect this one to be of player rocket type. Then I have the rocket. Here I should probably do an if to check if this actually return the correct thing. This returns like a optional OK at the, but anyways. And then here it uses both the rocket position, which is inside entity, and then the state, which is inside the player rocket variant. Yeah, so I just like that I can get some type safety on function parameters. Because that's very annoying problem with if you just I could send in the handle, and then I would have to resolve the handle somehow, and I would just have to hint in the name that this handle should be resolved to this type. I could send in the entity, but then I have all this problem of getting to the variant. I could send in the pointer to the variant directly, but then I don't have the common stuff for entity. But in this case, I get everything. So I think that's very nice, and it solves many problems that might seem small, but actually can be quite annoying. Because what you do in gameplay code is, you do a lot. Get the entity, do something with it, affect some other entity, back and forth. And then you want that to be smooth. See if there is something in the chat here. So why would entity store a handle to itself? That's probably not strictly necessary. The question is, why does entity have a handle here? I've used it sometimes because when you have an entity instance and you want to say like remove me from the game, then you want to have the handle or something like that. And I think I also use it inside my handle-based array code. But people have commented on this before, and maybe I'm just done something silly. But to me, it's slightly useful. And yeah. What more do we have here? Someone says that their entity system is just an entity megastruct. But yeah, I guess this could be a megastruct. And so I might have oversold that I came up with some new fancy entity system, but I was just trying to say that I am using sort of a big entity with a union, but with some added fancy stuff combined with the handle-based array to make it all work in sort of a smooth way. Yeah. I was thinking if there's anything more fun with this. Initially I was like, I didn't have an entity system at all. I just had lots of I think it's a good idea in the end to have some kind of system so you can have like some generalized code. But like I said at the beginning of this, that this is one of the biggest design decisions you make, because if you make too much gameplay code, it's very hard to change the system that stores and handles and dictates how entities interact with each other. So you need to get that stuff sort of right early. And I think this is sort of a fun way to work with entities that they're still very simple, but they are, the entity system is still very simple, but I can do some things to make it, like the syntax of it, slightly more powerful and stuff. I don't really have. I was mainly today gonna do just a demo actually. I wasn't planning. I'm in the middle of refactoring lots of stuff on the game, so it's just a bit of a mess actually. So what I'm doing currently is I'm trying to do some physics on this funny rocket here that I fly around with. And stuff. There's actually supposed to be a nice. This rocket is not supposed to be here in the beginning. It's supposed to be the last thing you get at this level. Actually, I can do this equals dot controlled. If I do this, I'm just gonna show a cute thing here that I worked on. So the last thing that happens in this level is that you're gonna get this rocket, and then I've actually made a funny little start sequence where everything starts shaking and then it flies away. And then, oh yeah, the camera got a bit weirder. And then you get to this next level where you're maybe out in space or something. I haven't. This is what I'm gonna work on currently, like the next stage and stuff. And then I also have lots of. I've made a lot of systems for talking and stuff. Yeah. But I think that's that for today, actually. I will probably use the recorded version of this live stream to make sort of a shorter video on these, whatever I talked about, without all the ums and ahs and But yeah, thank you for watching, and I will see you next time. Bye.